Right. So welcome to lecture number 14. What do we plan to do today? Let's just do that first. तो हमें जो है पॉइजन डिस्ट्रीब्यूशन समझना है. We want to understand the Poisson distribution, and we also want to understand and do a lot of problems, questions, practice, questions, PYQs. This is the last topic from chapter number 3, which is the discrete random variable. ठीक है? Chalo ji. Any doubts from whatever we've discussed so far? So the last thing that we discussed was the negative binomial distribution, not the negative binomial, the hypergeometric distribution. We started discussing that and we did a few examples based on that. Any doubts on that? All okay. Hi, Ashish. Good evening. Okay. Looks like everything is fine. So let's just get started. So dekho, what is Poisson distribution? Poisson probability distribution. So Poisson distribution is also a discrete random variable. Okay? What is the definition of this? Guys, just give me 10 seconds. Just quick 10 seconds. I'll just be back in 10. All right. So sorry for that. So, okay. What's the definition of Poisson probability distribution? So, a discrete random variable or this random variable we are representing with x. So this discrete random variable is said to have a Poisson probability distribution. Poisson distribution. And you know, we've kind of seen different kinds of distribution. जैसे हमने binomial distribution देखा, हमने hypergeometric distribution भी देखा, ठीक है? तो वहां पे अलग-अलग parameters होते हैं. What are the parameters for binomial distribution? So kind of वो values जो पूरे distribution को define करती हैं. तो binomial में small n and p used to define the entire distribution because you know, apart from knowing those two values, we did not really need to know anything else, right? In the hypergeometric distribution, what were the parameters? We needed to know what is capital N. We needed to know what is capital M. We also needed to know what is small n. These three were the parameters. Similarly, for this distribution, we have a parameter which is called mu. Okay. So a discrete random variable x is said to have a Poisson distribution with parameter value mu, with parameter mu, and mu has to be positive. If this is the PMF of the random variable, if the PMF of x, which is the probability mass function of x, is the following. तो अगर कोई एक डिस्ट्रीब्यूशन है जिसका PMF is given by whatever formula that I'm about to write, then that particular random variable is called a Poisson probability distribution or a Poisson random variable. Okay. So what is that probability? So probability of X with parameter value mu is nothing but e raised to the power minus mu, mu raised to the power X divided by X factorial. This looks like a complicated expression, but don't worry. It's very simple. Whatever your mu parameter is, just do e raised to the power minus mu. Whatever is the value of mu, just do the power x. So whatever is the value of x that you have, what all possible values x can take, let's just describe that as well. X can take value 0, 1, 2, and it can go on. Okay. So it's a discrete random variable, but it has, it doesn't have a finite amount of number. Finite number nahi hai ye. It can go till infinity. So the numbers could be 0, 1, 2, 3, 4, and it's an entire countably infinite sequence that we have. Okay. So this is what we have. This is what we have. This is the PMF of a Poisson distribution. Okay. Acha, can you tell me one thing, that for any PMF to be valid, what is the condition? What are the two conditions that we've studied for any PMF to be a valid PMF? Kya conditions padhe humne? So whenever we have to check if the PMF is valid or not, what do we check? First of all, for all possible values of x, is your probability greater than or equal to 0? That is first thing. Second thing, all the sum of your probabilities for all possible values of x, what should be the value of that sum? What should be the value of the sum?
1.
It should be 1, right? तो इसका मतलब जब अगर मैं ये निकालूं कि probability of 0 plus probability of 1 plus, if I keep doing that, that entire sum should be 1, right? So abhi jo hai na, right now you might not have too much of an experience with e raised to the power something, but soon enough, thode time mein, when we study exponential function in your mathematical methods for economics, there you will get a lot of experience with this. So I am just about to write an expression. Right now you just have to take it as a face value. Don't worry if you're not able to understand it. After some point of time, when you experience that in mathematics, you will be able to understand it. तो अभी जैसे मैं लिख रही हूँ, just take it on the face of it, face value पे ले लो और मान लो कि ये correct है, ठीक है? तो जब भी आप कोई expression e raised to the power x लिखते हो, तो उसको जो है किस तरीके से ब्रेक डाउन किया जा सकता है? 1 plus x plus x square divided by 2 factorial plus x cube divided by 3 factorial plus this expression can keep going on. ठीक है? Plus x raised to the power n divided by n factorial and it can keep going on. तो इसका मतलब क्या है कि e raised to the power x जो है उसको आप किस तरीके से expand कर सकते हो? You can expand it in this manner. ठीक है? All right. So what does that mean? Can I use this to show that sum of all these probabilities is going to be 1? That is my task. That is the task that I have. So let's see what happens. तो एक काम करो. What is P0 going to be? P0 is what? यहाँ पे P0 क्या होगा? E raised to the power minus mu, mu raised to the power 0 divided by 0 factorial. And what is this expression? What is this expression? E raised to the power minus mu. Anything raised to the power 0 is what?
1.
Anything raised to the power 0 is 1. And 0 factorial is what? By definition, 0 factorial is 1, right? So mu raised to the power 0 is 1 and 0 factorial is also 1. So this expression is nothing but e power minus mu, right? What is P1? E power minus mu divided by 1 factorial, right? What is P2? E raised to the power minus mu squared divided by 2 factorial, right? We can keep doing this. So if you just do this entire sum, what are you going to get? E power minus mu plus e power minus mu divided by 1 factorial plus e power minus mu squared divided by 2 factorial. You can keep doing that and it'll keep going on, right? Everywhere I'm getting e power minus mu, e power minus mu, e power minus mu, e power minus mu. Everywhere I'm getting this only. Can I take that common? इसको common ले सकते हैं, right? So I'll just take e power minus mu common. What do I get? 1 plus mu divided by 1 factorial plus mu squared divided by 2 factorial plus it'll be actually mu cubed divided by 3 factorial. It can keep going on, right? Now, does this look familiar to you? What is the expression inside of this bracket? कौन सा expression है ये? Can you see the pattern? Can you see this and this? Are they similar? They're following the pattern. So what is this inside? If we had x here, it was e power x. Now we have mu here. So what is this entire sum going to be? E power mu? Right? Yes or no?
Ma'am, but we do not have mu. We have it. Yes, ma'am.
Yeah. Okay. So whatever is inside, that will be e power mu. So outside I have e power minus mu and inside I have e power mu, right? So what is this? E raised to the power minus mu plus mu. What is this? E power 0. And what is e power 0? 1. Any to the power 0 is 1. So that kind of justifies that, okay, this is a valid PMF because the sum of this entire probabilities, sum of all these probabilities is going to give me 1, right? So it's a valid PMF. All right. So, you know, this particular expansion, we call it, there's a specific name for it. It's called Maclaurin series expansion of e raised to the power x. अभी जब आप आगे जाके एक्सपोनेंशियल फंक्शंस पढ़ोगे, देयर यू आर गोइंग टू गेट इट, ठीक है? आगे जाके अभी हम लोग मैथमेटिक्स में टेलर सीरीज एक्सपेंशन भी करेंगे, वहां पे ऑल्सो यू आर गोइंग टू गेट दिस, ठीक है? सो फार सो गुड, फाइन,
Yes, ma'am.
ठीक है? तो अब आपका टास्क क्या है? कोई भी डिस्ट्रीब्यूशन, अच्छा ठीक है, ये डिस्ट्रीब्यूशन का पीएमएफ तो हम समझ गए, बट इसका एप्लीकेशन कहाँ पे होता है? जैसे बाइनोमियल डिस्ट्रीब्यूशन के लिए वी प्रेजेंटेड अ स्टोरी, नेगेटिव बाइनोमियल, नॉट नेगेटिव बाइनोमियल, हाइपरज्योमेट्रिक के लिए ऑल्सो वी प्रेजेंटेड अ स्टोरी. व्हाट काइंड ऑफ थिंग्स यू आर एबल टू मॉडल दिस? तो जैसे कि सपोज यू नो in the real world, let's say I'm talking about a situation, is that let's say, you know, there's a website, and let's say I am saying that, you know, I have a 1 hour time frame, 1 hour time frame. So in this 1 hour time frame, how many people can visit this website? If I have to model this behavior, I can use Poisson distribution for that. You know, it can very well happen that nobody visits this website. If this website is not very popular, nobody is going to visit this website. So there are 0 people visiting this website. That will also have some probability. There is 1 person who's visiting this, 2%, 3%, 1 crore people. So there could be any number of amount of people who could be visiting this website, right? If this website is Instagram, millions of people are visiting it every single day. I mean, not day, in minutes also. Millions of people are visiting this, right? If let's say this is some non-pop, any website you're talking about, someday let's say there is some downtime which is going on in this website, nobody is able to access it, right? तो हो सकता है कि ये जो वेबसाइट है इस पे देयर इज नो पर्सन कमिंग और वन पर्सन कमिंग और टू पीपल कमिंग, थिंग्स लाइक दैट, राइट? So if we have events like this, wherein we don't really know, we can have no amount of people also, we can have so many people also coming up. इस तरीके के जो बिहेवियर को जब आप मॉडल करते हो, देन वी यूज पॉइजन डिस्ट्रीब्यूशन. और क्या एग्जाम्पल हो सकता है? जैसे कि फॉर एग्जाम्पल वी कैन से दैट वी हैव अ शॉप एंड लेट्स से इट्स 12 PM राइट नाउ. सो वी आर सेइंग 12 PM से 1 PM के बीच में हाउ मेनी पीपल आर गोइंग टू विजिट दिस शॉप. So if let's say there's some lockdown going on, हो सकता है कोई ना आए, nobody enters your shop. हो सकता है एक इंसान आए, दो इंसान आए, या मान लो आपने कोई ऑफर रन किया हुआ है या सडनली बहुत लोगों की छुट्टी है, many people turn up, right? So the number of people who can come to the shop is 0, 1, 2, 3, or it can keep going on, right? Obviously in shop there's a limit of maximum amount of people who can enter. I mean, because it's a physical space, there's a limit to it. But in general, how do you model this behavior? Such kind of behaviors can be modeled using the Poisson distribution. ठीक है? तो इस तरीके के जब भी आप एग्जाम्पल देखो कि एक गिवन टाइम फ्रेम में कितने लोग एंट्री कर रहे हैं, कितने लोग एग्जिट कर रहे हैं, कितने लोग विजिट कर रहे हैं, इस तरीके का जो भी हमारा प्रैक्टिकल वर्ल्ड में एप्लीकेशन होता है, उसमें हम लोग पॉइजन डिस्ट्रीब्यूशन यूज करते हैं विद अप्रोप्रिएट एवरेज. जो म्यू होती है ना, म्यू, आप देखोगे जो म्यू पैरामीटर है, दिस इज ऑल्सो द एक्सपेक्टेड वैल्यू ऑफ दिस रैंडम वेरिएबल. तो म्यू क्या होगा? ऑन एन एवरेज हाउ मेनी पीपल विजिट योर शॉप, या ऑन एन एवरेज हाउ मेनी पीपल विजिट योर वेबसाइट, समथिंग लाइक दैट. ठीक है? तो म्यू जो मेरा पैरामीटर होता है, दैट इज ऑल्सो द एक्सपेक्टेड वैल्यू ऑफ दिस रैंडम वेरिएबल. So based on my average value, we will see, okay, people less than that turn up, higher than that turn up, things like that. Is the example clear? All good with that? Okay, fine. So first of all, we need to understand what is the expect. अब ये रैंडम वेरिएबल समझ लिया, इसका डेफिनेशन समझ लिया, ठीक है, और ये पीएमएफ इसका वैलिड है, ये भी हमने प्रूव कर दिया, ठीक है. अब एग्जाम्पल भी समझ लिया. अब हमारा जो नेक्स्ट टास्क है वो ये जानना है कि ये जो रैंडम वेरिएबल है उसकी एक्सपेक्टेड वैल्यू और उसकी वेरिएंस और उसका स्टैंडर्ड डिविएशन क्या होता है, ठीक है. सो व्हाट इज द मीन एंड वेरिएंस एंड स्टैंडर्ड डिविएशन ऑफ अ पॉइजन डिस्ट्रीब्यूशन, ठीक है. मीन एंड वेरिएंस ऑफ एक्स, ठीक है. तो आई कैन जस्ट टेल यू राइट अवे कि इसका मीन और वेरिएंस क्या होगा, बट इट विल बी इंटरेस्टिंग टू प्रूव दैट एज वेल, ठीक है. तो अगर if x has a Poisson distribution with parameter mu, then expected value of x जब आप निकालोगे तो वो भी mu आएगी, और जब आप variance value निकालोगे वो भी mu आएगी. Variance of x is also mu, expected value of x is also mu, and by that continuation standard deviation of x is going to be square root of mu. ठीक है. अब ये आया कैसे? How did this came? ये कैसे आया? इसको कैसे प्रूव करें? तो क्या करना पड़ेगा? What is the expected value of x? What's the formula for finding expected value of x? What should we do? What's the formula for finding the expected value of a discrete random variable? What do? Summation of what? Probability times what is the value of x? And for all possible values of x, what are the possible values here? Going from 0 to infinity. X can take any number of values, right? Are we good this far? ठीक है. तो क्या करना पड़ेगा now? What should we do? So expected value of x is what? What is this probability number? ये probability number क्या है? This is e power minus mu raised to the power x, right? And divided by x.
Excuse me, ma'am.
Yeah. Go ahead.
Ma'am, there was a power cut, so I couldn't hear what you said.
Okay. So what was the last thing that you heard?
Ma'am, that expectation.
Okay. So what we are trying to do is we are just trying to figure out the mean and variance of x. And so I'm just telling you what is the mean. Mean is going to be mu, variance is going to be mu, and since variance is mu, the standard deviation will be root of mu. And now what we are trying to do is we are trying to figure out how to prove this. Okay. तो हम इसको प्रूव करने की कोशिश कर रहे हैं और we know that expected value of a discrete random variable, how do you figure it out? Whatever is your probability number, you multiply it by the x value and you do this summation all across values, right? So this is the formula. Now what we are trying to do is simply put this p value. What is this p value? This p value is e power minus mu raised to the power x divided by x factorial. And then I just have to multiply it by x and then just do this summation of x going from 0 to infinity, right? Are we good this far?
Okay.
Okay. Any doubts in this? You know, you can be asked such questions in paper. Find the expected value, prove that the expected value is this. You can be asked these questions. So it's not just we're not doing this for entertainment. ये सब हो सकता है. ठीक है? तो उसके बाद क्या करेंगे? Any ideas? What should we do? Let's try to open it up and see the pattern. इसको खोलते हैं और फिर पैटर्न समझते हैं. देखो ये जो expected value of x है ये क्या हो जाएगा? If you start with x value 0, the first term is going to be 0, right? Second term क्या हो जाएगी? 1. तो मतलब एक काम कर सकते थे, अगर मेरी पहली टर्म 0 है तो क्या मैं इसको ऐसे लिख सकती हूँ? Summation x going from 1 to infinity e power minus mu raised to the power x times x divided by x factorial. Can I do that? Because the first term, which was when x value was 0, didn't really make a difference because the first term kind of got vanished, right? Nothing really mattered there. Yes or no?
Ma'am, I didn't get that.
So, okay. Okay. Let's say if I have to sum this, that, summation x, and I'm saying x value going from 0 to n. So what am I going to do here? This is basically 0 plus 1 plus 2 plus up to n, right? I could have just done this also, na? Ki, do this summation x and x value is going from 1 to n. Because that is also 1 plus 2 plus 3 up to n only. This value didn't really make a difference to this entire sum, right? 0, because it was 0.
Yes, ma'am. Yes.
That same logic we are applying here. That because this term was 0, this was 0. So it really didn't add anything here. So what I did, rather than starting from 0, I just said, okay, let's start from 1. Okay. So now what do we do here? Okay. Can I write it in a different manner like this? Expected value of x is this. It can be this, right? Summation x going from 1 to infinity e power minus mu power x and times this is x divided by x factorial. Can I write it like x times x minus 1 factorial? Can I do that?
Yes, ma'am.
Right. So what can you do? You can just do this, right? You can cancel these two things. X and X can get cancelled, right? So what do you have here? What I'll be left with is this summation x going from 1 to infinity e power minus mu power x divided by x minus 1 factorial, right? Acha, can I do one thing? Can I convert my variable from x going from 1? So let's say that x minus 1. Suppose x minus 1. I'm calling x minus 1 as y. Okay. So when x value is 1, what is the value of y?
0.
0. And when x value is infinite, what is the value of y? Y is infinite minus 1, which is also infinite, right? Yes? Because if you remove one number from infinite, it's not really going to make any difference, right? So, aap kya karo? What you have to do is, instead, wherever x is written, just write y plus 1. So, wherever you see x, just write y plus 1, right? So, just do that. So, if we do that, what do we get? This summation is going from x value 1, meaning y value 0, and infinity. What is this? Is e power minus mu raised to the power x. X को मैं कैसे लिख सकती हूँ? Y plus 1 divided by, what is x minus 1 factorial? This is actually y factorial. Yes or no? Right. So this is basically called changing the variables. Changing the variables. Can I do that? This is fine.
Ma'am, it should have been y plus 1 equals to 0, right?
Y plus 1 equals to 0. Here?
Ma'am, under that sigma, I didn't get that.
Yeah, so we are starting from x value 1. So whenever x value is 1, we have y value should be 0, right?
Oh, okay, ma'am. Yes.
Yeah,
Yes.
so that's why like whatever is the starting point here should also be the starting point here. Okay.
Yes, ma'am. It takes time for me to click that.
No, it's fine. It's fine. It's good that you're asking your doubts. It's fine. Take your time. आराम से कोई जल्दी नहीं है. ठीक है. इसके बाद, can you see anything emerging? Can I write it like this? Can I do that?
Yes, ma'am.
Right? And this mu is not going to change when this y value is changing. So I can bring it outside also. So this is mu summation y going from 0 to infinity e power minus mu raised to the power y divided by y factorial, right? And can you see what is this? What is this? Just see what is this? What was this? Basically, if we add this when x is going from 0 to infinity, this entire sum should be 1, right? Because it's the sum of all these probability values, right? Yes. So it's the sum of all possible probabilities that I have here. yes, no,
Yes, ma'am.
right? तो ये पूरा सम क्या होगा? This entire sum should be 1 because sum of the probabilities in PMF, right? Which should be 1. So this entire expression is mu times 1. So this just gives me mu. And that is my expected value of x. Right? यही तो करना था. So we have proved that indeed the mean value of a Poisson distribution is mu. Right?
Okay, ma'am.
Fine. ठीक है. अब ऐसे ही आपको वेरिएंस वैल्यू के लिए निकालना है. ठीक है. वेरिएंस वैल्यू के लिए भी आपको सेम ही चीजें करनी है. तो वेरिएंस कैसे निकालते हैं? हाउ डू यू फाइंड वेरिएंस? Priyank, Ashish, guys, is this okay? Any doubts in this? All good? Yes. Okay, great. No doubts. Perfect. Very nice. ठीक है. तो अब वेरिएंस कैसे निकालेंगे? हाउ डू यू फाइंड वेरिएंस? वेरिएंस अगर निकालनी हो तो वेरिएंस का फॉर्मूला क्या होता है? I will just need to do this expected value of x minus mu entire squared, right? Or I can find this expected value of x square minus expected value of x entire squared. Yes or no? ठीक है. तो फिर करें इसको. कैसे करना है? How will we do this? So basically I already have this value. Right? And what is this value? Variance of x is equals to expected value of x square minus mu squared. I kind of know that my variance value is mu because I already told you. So what should be expected value of x square? I already told you that this is mu, right? So what should be the value of expected value of x square? It should somehow come out to be mu plus mu square. Yes or no? So your goal in life is to figure out how do we prove that expected value of x square is mu plus mu squared, right? यही करना है हमें.
Yes.
राइट. तो अब हमारा टास्क सिंपल सा है कि हमें पता है कि हमें ये शो करके वी हैव टू शो दिस शुड ऑलवेज बी इन आवर माइंड कि हमें ये प्रूव करना है. तो हम क्या करते हैं? लेट्स जस्ट फोकस ऑन फिगरिंग आउट व्हाट इज दिस. सो व्हाट इज एक्सपेक्टेड वैल्यू ऑफ एक्स स्क्वायर? हाउ डू यू फिगर इट आउट? Expected value of x square is nothing. Again, same thing, x going from 0 to infinity. You put x square and then you have your probability value, right? So just write what is the probability value here. Summation x going from 0 to infinity, x squared, right? And what is px? E power minus mu raised to the power x divided by x factorial, right? है ना? यही है.
Yes, ma'am.
ठीक है. अच्छा जी. तो नाउ आवर गोल इज टू मैनिपुलेट इट समहाउ. ठीक है. तो पहली चीज जो हम यहाँ पे कर सकते हैं वो क्या हो जाएगी कि मैं इसको ऐसे कर सकती हूँ. समेशन x value going from 1 to infinity x square e power minus mu power x divided by x factorial. Can I do that? The same thing that we did earlier as well.
Yes.
Right. अब उसके बाद can I write this x square e power minus mu power x factorial को I can write x times x minus 1 factorial, right? And then this is the summation, x going from 1 to infinity. And then this is the expression, right? So you'll just cancel this with this. So what are you left with? Summation x going from 1 to infinity, x times e power minus mu times mu power x divided by x minus 1 factorial, right? Okay.
Okay, ma'am.
Right. Now, let's try to replace again, same thing. What we can do is here, instead of x minus 1, let's just try to replace it with y. Okay. So, okay. Now, whenever x value is going to 1, where is y value going? Whenever x is 1, y is going to 0. And whenever x is going to infinity, y is also going to infinity. These two things we are fine with. Right? So let's just try to replace the variables again here. तो आप क्या कर सकते हो यहाँ पे? Let's do that. So wherever we see, we can just write y going from 0 to infinity. Okay. And what is this now? Instead of x, this is x here, right? So instead of x, what can I write? Y plus 1. And I have e power minus mu here. And mu raised to the power y plus 1 here. And instead of x minus 1 factorial, I can put y factorial, right? This is my expected value of x square that I'm trying to figure out, right? So far, so good?
Yes.
ठीक है. तो अब जो है थोड़ा सा देखते हैं इसको और कैसे ब्रेक डाउन कर सकते हैं. ठीक है. तो देखो फिर इसको और क्या कर सकते हैं हम लोग. One thing which will keep bothering me again and again is this extra plus 1. So we can just bring mu outside, one value of mu outside, and it's constant everywhere. So we'll just bring mu outside. So mu summation y going from 0 to infinity, y plus 1 e power minus mu power y divided by y factorial, right? And what can I do? Let's just multiply both sides by this. I mean, this can be multiplied by y and this can also be multiplied by 1. So let's do that. So this is mu. And because summation can be broken down into these two parts, so it can be like this. Y going from 0 to infinity, y e power minus mu power y divided by y factorial plus summation y going from 0 to infinity e power minus mu raised to the power y divided by y factorial. And then this entire bracket is closed. Okay. Are we okay with this step? What did we do? Isko isse we have multiplied and isse bhi we have multiplied. And then we've just broken down the summation here separately and then here separately, right? Fine. ठीक है. तो अब ये बताओ ये क्या है? ये तो देखा देखा लग रहा है. Does this look familiar? What is this? And does this also look familiar? What is this? क्या है ये?
Y plus 1.
So this is basically ये मेरी y वैल्यू टाइम्स प्रोबेबिलिटी ऑफ y. तो एक तरीके से ये मेरी एक्सपेक्टेड वैल्यू हो गई. यहाँ पे y की जगह अगर सिर्फ x लिखा होता तो सारा एवरीथिंग इज एग्जैक्टली द सेम, राइट? This is my y value, this is my probability of y, and this is my probability of y, right? So this is my sum of probabilities, And this is my expected value of Poisson random variable, right? And what is the expected value of a Poisson random variable? Mu. And what is the sum of all the possible probabilities? 1. Right?
Ma'am, in the first part, it should be y into 1, right? So it's like
Y into?
1.
No. So like, जैसे जैसे this Y value is changing, I can't bring Y outside, na? Because Y is also changing. The only thing that you can bring outside is the constant values.
Yes, ma'am.
Right? So basically, this, when we were finding expected value of X, we were doing this. We were doing this only, na? See this? Exactly the same, except now instead of X, here we have Y. Right? That's the only difference. Right?
Yes, ma'am.
So this is actually my expected value of X, which will come out to be mu. And then this is sum of all possible probabilities, which is 1. So if you do this addition, what do you get? This is mu square plus mu. And this is my expected value of X square. And this is exactly what we wanted, right? यही तो चाहिए था, है ना? This is what we wanted. And then what is the variance of X? Expected value of X square minus expected value of X whole squared. This value is mu square plus mu. And what is this value? Minus of mu squared. So what is this value again? Mu. Right? Perfect. All good with this? Are we clear how to do this? How to prove that the mean value and the variance value is mu? Both are mu. So it's just how to simply play with summations. That's it. Okay, G. So I hope you will be able to do and attempt problems like these if they come in exam. Good. Okay, perfect. Just one small thing. Your Poisson distribution, it can approximate. So basically, you remember binomial distribution? So we have a binomial distribution. What are the parameters for a binomial distribution? We represent by binomial distribution as B of X, and the parameters are n value and p value, right? N value is the number of trials that I'm going to have, and p value is the probability of success in each trial, right? For the Poisson distribution, my distribution is like this, and the parameter value is mu, which is also my average value, expected value of X, right? So, we see that whenever this n value becomes very, very large. So what are we saying? That suppose, so we have a proposition here. Proposition is basically any statement which is true. So I am telling you a proposition, something which is going to be true. So what is this? That suppose that in the binomial distribution, and also guys, just, okay, this is apart from what I'm supposed to tell you here, like away from topic. I would like to show you how all these distributions look like. And like whatever this proposition that I'm saying, that if n value is going very high, p value is going very less, this distribution will tend to Poisson. I would like to show you on graph. So there are tools online, very nice statistical tools, which let you play around with these n values and p values. And it'll be very interesting to see. So, I mean, once we are done with that, I would like to show you that graphically also, so that you get a little bit of a feel of how these distributions look like. Right now, I can understand these might be very, very dry for you, but that will give you, I mean, good amount of excitement regarding how these things approximate. So once we are done with this topic, I would let you see those graphs. Okay. All right. Chalo, let's do that. So what are we saying? Suppose that if we have my binomial distribution, suppose in the binomial distribution, binomial PMF, my binomial PMF is this, right? And suppose we are saying that we let the number of trials tend to infinity, meaning my number of trials is very, very high. What am I doing? I'm letting my number of trials to become very, very high. Okay. And my p-value, which is my probability of success, is also going to be a very, very small number. So if my p-value is very close to 0, so this sign is tending to, meaning limit value, tending to. So n value is tending to infinity, meaning n value is a very large number. P-value is tending to 0, meaning p-value is something which is very, very close to 0. So probability of success is becoming very close to 0, such that, and how are you making these numbers change such that, n times p. What is n times p? This is my average value in my binomial distribution, right? Average value in the binomial distribution. So what am I doing? I am letting my n value go to a very large number, and I'm letting my p value go to a very small number, such that this n times p product remains the same, such that this n times p product remains the same, and this n times p is equal to, this n times p approaches, this approaches a value mu, such that this mu value is greater than 0. Okay. So how are we letting n and p change? That n is becoming very, very large and p is becoming very, very small, such that this product n times p, it's fixed and it's approaching a number mu. And what is this mu? This is actually my average value in my Poisson distribution. So in that case, so this is all the background first we are setting up, that this is the kind of situation that we are putting ourselves into. Now what happens? So if this is the situation, then we can say that this binomial distribution PMF that we have, it will approach the Poisson distribution. So what are we saying? That if this is the situation that your n value is tending to infinity, your p value is tending to 0, such that this n times p is equals to mu, then whatever this binomial PDF that you have, this will approximately, this will tend to your Poisson distribution. So this distribution will exactly try to tend to the Poisson distribution. This is the meaning of it. So if your n value is large, and if your p value is becoming very, very low, whatever is the distribution meaning at different x values, you have different probabilities value. And for this also, at different x values, you will have different probabilities. So what this term means that if I try to find b of 0, so that will be very close to p of 0. If I try to find b of 1, it will be very close to p of 1. Things like that. That is what we mean. So whenever this happens, that n is very large and p is very small, and n times p is equals to some constant mu, so then this distribution will become very close to this Poisson distribution. This is your proposition. Is this statement clear? So binomial distribution in the limit, it tends to Poisson distribution. So it becomes very, very close to Poisson distribution. Is that all right?
Yes, ma'am.
Okay. So practically, if there are some situations wherein you might have to apply this approximation, what is it that you have to keep in mind? That, so what are we saying? According to this proposition, if we have a binomial experiment, in any binomial experiment, in which n is large and p is small, such that this n times p is equals to mu, then we are saying that this binomial PDF will approximate the Poisson PDF. Okay. And as a rule of thumb, you know, what is the meaning of n is large? N could be 100, n could be 1000. There should be some limit to it. Na? So we have a rule of thumb. It's not a hard and fast rule, but it's basically the number after which we've seen this convergence to be a good enough approximation. So as a rule of thumb, this approximation can be applied if your n value is greater than 50 and your n times p product is less than 5. So if you see your n value to be, greater than 50 and your n times p value to be less than 5, which is basically your mu value to be less than 5, you should be able to do this approximation. So if you have to figure out some probability value, you can simply use the Poisson formula for finding that probability. Is that fine? So you can just keep these two numbers in mind. If n value is greater than 50, that is considered large enough. And your n times p, that should be basically, less than 5. All right. So under these circumstances, you can apply this approximation. Okay, fine.
Yes,
Okay, G. All right. So that's pretty much it that we were supposed to do in this chapter. We will do some questions now related to Poisson distribution only. And I would also like to show you this, different distributions. How do they look like on graph? Okay. So let's take a quick 10 minutes break now. And after the break, let's continue the questions and the graph portion that we are supposed to do. Okay. So it's 7:12 right now. Let's meet at 7:25. Okay. Let's start again at 7:25. Thank you. All right. So this is one question which is related to the Poisson process. Let's see. So let's read the question first and see isko kaise apply karna hai. So what is it saying? It is suggested that the number of people arriving per hour in a bank follows a Poisson process. So you see, एक time bracket है 1 hour, उसमें एक बैंक में कितने लोग आ रहे हैं, that is following a Poisson process. And what are they saying? On average, 5 people arrive per hour. So they have also given you the average value of this. Okay? So number of people arriving in a bank per hour, that is given as, basically that follows a Poisson process. So this is basically X, which is following a Poisson distribution. And the average number of people who are arriving per hour is 5. So what have they given you? Expected value of x is equals to mu is equals to 5. So 5 people per hour on an average arrive in this bank. ठीक है? All right. उसके बाद यहां तक कोई डाउट है? ये चीज समझ में आ गई? Why is this 5? Why is mu 5? ठीक है, चलो, okay. So what next are they saying? As a precautionary measure to avoid the spread of coronavirus, suppose that the bank cannot allow more than 10 people to enter in a given hour. So you know this particular paper, ये जो question आया था, this was during your COVID times. When university conducted online papers. So जो online paper हुए थे तब ये question आया था. So for 2 years, university conducted online papers, and you guys used to have online classes. Just last year से जो है classes offline शुरू हुई हैं. उसके अलावा 21 entire and kind of some portion of 2020 entirely was online. 2021 was almost everything was online. Then basically this question was asked. So what are they saying? In order to avoid the spread of coronavirus, bank cannot allow more than 10 people to enter in a given hour. So 10 people, more than 10 people are not allowed inside the bank in an hour. Okay, fine. So we've understood what they are saying. Now let's see what is being asked. So the question first part is, what is the probability that in a given hour, the bank staff can no longer allow more people to enter? तो उस चीज की प्रोबेबिलिटी बताओ कि बैंक को मजबूर होना पड़े और ये बोलना पड़े कि प्लीज द गेट इज क्लोज्ड, वी कैन नॉट अलाउ मोर पीपल टू एंटर. तो अगर कोई भी इंसान नहीं आया तो बैंक डजंट नीड टू से दिस. सो बेसिकली इसको आप ऐसे समझ सकते हो कि अंडर व्हाट कंडीशन बैंक विल, यू नो, लेट्स से बैंक हैज अ बोर्ड, यू नो, दे हैव अ बोर्ड लाइक दिस, लेट्स से, एंड उस बोर्ड पे लिखा हुआ है नो एंट्री. तो मतलब आप बस ये बोलो कि ये बोर्ड लगाने की जरूरत कब पड़ेगी, ये क्वेश्चन है. व्हाट इज द प्रोबेबिलिटी दैट इन एनी गिवन आवर द बैंक स्टाफ कैन नो लॉन्गर अलाउ मोर पीपल टू एंटर? So when will bank not allow more people to enter if how many people have entered?
10.
So if 10 people enter, they will allow more people or not? No.
No, ma'am.
If 11 तो हो ही नहीं सकता, right? So if the number of people who line up to be inside the bank is greater than or equal to 10, then we can't allow more people to enter, right? Yes or no?
Yes, ma'am.
Right. So what am I looking for? The probability that my random variable is taking either a value of 10 or greater than 10, right? Only then the bank will say you are not allowed. Should we include 10 or not?
Ma'am, that shouldn't be included.
It should not be. Okay, why?
Because till 10 it's okay, right?
Till 10 it's okay, but the moment 11th person comes, then they will not allow. But
So it should be greater than.
the moment 10th person comes, even then only the bank cannot allow, right? So like if 10 people,
Yes, ma'am.
it will still not allow, right?
Yes, ma'am. From the moment he enters, they'll put the board.
They'll put the board and say no entry allowed, right? So we should include 10 here as well. कि भाई इसके बाद हम allow नहीं कर सकते. So the moment you have 10 people in the bank, we are saying it's done. We can't allow more people. So what are we supposed to find? probability that x is greater than equal to 10, right? Is that fine? Is that okay? ठीक है, अच्छा, अब इसको कैसे निकालना है वो तो हम देखेंगे, बट फर्स्ट पार्ट में हमें ये निकालना है, ठीक है? दिस इज व्हाट वी हैव टू फिगर आउट. Okay, what about the second part? What is the probability that more than 20 people enter the bank during a 3-hour period? So, this is a property of a Poisson distribution that, if you have, we were considering that the number of people who are arriving in a bank per hour is a Poisson distribution. So the number of people who arrive in a 3-hour window is also a Poisson distribution. The number of people who enter in a 10-hour window is also a Poisson distribution. So you can increase your time frame and your average value will also increase by that multiple. So if I create a new random variable y, which is the number of people who enter the bank in a 3-hour window, that is also a Poisson distribution. And every hour, what was the average number of people who used to enter the bank? 5. And now I have 3-hour window. So what is the average number of people who will enter the bank in a 3-hour window? That will be how much? Agar every hour 5 people on an average enter. So in 3 hours, how many people enter on average?
15.
15. So this y becomes a Poisson distribution, with parameter value 15. Okay. So जब आपका टाइम किसी मल्टीपल से मल्टीप्लाई होता है तो आपकी एवरेज वैल्यू भी उस मल्टीपल से मल्टीप्लाई होती है. ये प्रॉपर्टी है पॉइसन डिस्ट्रीब्यूशन की. ठीक है, कि अगर मेरी म्यू वैल्यू चेंज हो रही है तो अगर मेरी टाइम फ्रेम चेंज हो जाती है इस तरीके से, मान लो 3 आवर की जगह 2 आवर कर देते तो वी वुड हैव डन 10 people एवरेज ऑन एन एवरेज एंटरिंग द बैंक. और इस सिचुएशन में आपको क्या निकालना है? What is the probability that more than 20 people enter the bank during a 3-hour window? So basically, what are you supposed to figure out here? What is the probability that y is more than 20? They have asked, not 20, more than 20, right? So y value is greater than 20. You have to figure out this probability. Is that okay? So far, so good. ठीक है, तो ये 2 चीजें निकालनी है. अब मैन्युअली तो हम नहीं निकाल सकते, मैन्युअली तो निकालना पॉसिबल नहीं है, तो हो सकता है इसके लिए भी कोई ना कोई टेबल हो. सो अगर इसको आप देखोगे तो इसको मैं ऐसे लिख सकती हूँ, प्रोबेबिलिटी ऑफ y दिस इज ग्रेटर देन इक्वल टू 21, राइट? तो मेरे को क्या करना है? समेशन y वैल्यू गोइंग फ्रॉम व्हाट टू व्हाट, 21 टू इनफाइनाइट, राइट? एंड दिस वैल्यू e पावर माइनस म्यू, म्यू कितना है यहाँ पे? 15. म्यू पावर y डिवाइडेड बाय y फैक्टोरियल. तो ये सारी वैल्यूज को आप सम करोगे और ये जो भी आंसर आएगा दैट विल बी योर आंसर, राइट? अब ये कैसे निकालना है? इसके लिए हमारे पास टेबल होती है. सिमिलरली इफ यू आर सपोज टू फाइंड दिस, व्हाट कैन यू डू? दिस विल बी नथिंग बट आपको अपनी समेशन प्रोबेबिलिटी, कौन सी प्रोबेबिलिटी को ऐड करना है? x गोइंग फ्रॉम 10 टू इंफिनिटी e पावर माइनस म्यू. इस केस में म्यू की वैल्यू कितनी है? 5 रेज टू द पावर x डिवाइडेड बाय x फैक्टोरियल, राइट? So you can just write in symbol terms that it is going to be this. अब exact number क्या होगा उसके लिए we have a table. Are we good this far? Any doubts in this?
Clear, ma'am.
Clear? Ashish, Priyank, guys, all good? Okay, Priyank is fine. Good, thank you. Okay, Ashish is also fine. Okay, chalo. So now let's see how to read the tables. So last time we did the cumulative distribution tables for binomial distribution. Similarly, you have other tables also. So let's see, statistical tables. You can check in the group. I will reshare in case you don't have access to that. Yeah, so you must have the tables with you. Can you see my screen? Okay, yeah.
Yes, ma'am.
ठीक है, तो इसमें जब आप ये देखोगे तो देखो लास्ट टाइम हमने ये टेबल स्टडी किए थे, टेबल फर्स्ट टेबल विच वाज द बाइनोमियल क्यूमुलेटिव टेबल. अब इसके बाद जो हमारी दूसरी टेबल है वो ये है, टेबल A.2, दिस वन. व्हाट इज दिस? दिस इज क्यूमुलेटिव पॉइजन प्रोबेबिलिटी. तो जैसे कि लास्ट टाइम ऑल्सो आई सेड दैट व्हेनेवर यू रीड अ टेबल, जस्ट see on the left hand or right hand side, wherever, what are they trying to do. So what is this doing? This is telling you the CDF value. So y value going from 0 to x, and it's summing all those values, all those probabilities, right? So यहाँ पे they have given you mu value. So based on different mu values. So whatever mu values there are, they've given you this. And whatever different x values are there, they've also given you that. ठीक है? तो यहाँ पे जो पूरा पैरामीटर है, it's only dependent on mu. So you see 0.1, 0.2, 0.3 till 1. And then on this side, they have value 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, and 20. And that's it. That's it. यहाँ तक इन्होंने ये values दी हैं. म्यू की वैल्यू ये है, और ये जो है आपके अलग अलग एक्स वैल्यूज हैं. ठीक है, तो जैसे कि हमारे क्वेश्चन में क्या दिया हुआ था, वी हैड टू फिगर आउट probability that x value is greater than equal to 10, right? तो इसको मैं 1 माइनस probability that x is less than or equal to 9 ऐसे कर सकती हूँ, right? मुझे probability निकालनी थी that my x value, which is number of people who enter the bank, is greater than or equal to 10. तो इसको मैं 1 minus the number of people such that number of people is less than equal to 9 ऐसे निकाल सकती हूँ. Can I figure it out like that?
Yes, ma'am.
Right? तो what is your x value? 9. ठीक है? My x value here is 9 because I'll sum from 0 to 9. And what is my mu value in this case? My mu value was 5. So I will look for 5, which is this. 5 is here, right? ये 5 है. And in 5, I will look for value 9. So 9 value was this, right? 9 value is this. So 0.968. उसको 1 में से 0.968 माइनस करेंगे. So that is the probability that the bank will say that please don't enter the bank. We are full. We are running on full capacity. So this is your probability that x random variable is taking value less than equal to 9. And उसमें से जब आप 1 subtract कर दोगे, so basically आपके पास क्या आ जाएगा? 0.032, right? That will be 0.032. Yes or no? So simply what you have to do, figure out what is the value of x. Different values of x will be there. and what is your mu value. And that's how you can figure it out. This is your CDF value. And in the next question, what did we have to find? That,
Ma'am,
yeah.
ma'am, if we have to find the probability of x greater than or equal to 9, then that is also going to be 0.968.
If we have to find the probability of
X greater than or equal to 9.
ग्रेटर देन और इक्वल टू 9 अगर निकालना है, तो वो क्या होगी? 1 माइनस प्रोबेबिलिटी दैट x इज लेस देन इक्वल टू 8.
Oh, okay.
राइट? तो आप वो लेस देन इक्वल टू 8 ये वाला नंबर हो जाएगा और उसको 1 में से माइनस कर दोगे.
Yes, ma'am.
राइट? लाइक दैट. ओके, जो इसका सेकंड पोर्शन था उसमें हमें क्या निकालना था? Probability that my random variable is taking a value which is greater than or equal to 21. And what was my mu value later on? 15. So I will go here. This is mu value 15. I will go here. And there, what will I do? This is 15. And on 15, I will look for the number. So basically, I have to find probability that y is greater than equal to 21. It will be 1 minus probability that y is less than equal to 20. 21 और उससे बड़ा चाहिए तो माइनस जब करेंगे तो 20 या उससे छोटा. So I will look for my number 20 here, and which is somewhere here, right? So this is 917, right? This is 917. Yes, 917, right? तो हमारा जो आंसर है वो क्या हो जाएगा? 1 minus 0.917. 1 minus probability that y is less than equal to 20, which is equals to 1 minus 0.917, which will be equal to 0.083. That is your probability. Okay? It's very simple to read this table. Can we do it? Can we read this table? So the important thing is mu and your x value. Okay? And this table is giving you a CDF value. ओके, CDF वैल्यू ये दे रहा है आपको. फाइन, ऑल गुड.
Yes, ma'am.
ठीक है, आशीष, प्रियांक, ऑल गुड. ऑल राइट. ओके, सो नाउ मूविंग ऑन टू, सो बेसिकली ये टेबल हमें समझनी थी, प्रॉब्लम्स भी इसी तरीके से आएंगे. ठीक है, so you should be able to practice everything now. Whatever concepts are supposed to be done from chapter 3, that is done. जो हमारी अगली क्लास होगी उसमें हम लोग chapter 4 स्टार्ट करेंगे. But before that, I would just like to leave you and show you a few beautiful graphs. So let's just do that first. Just give me a moment. Okay, fine. Okay, let me start sharing my screen. Can you see my screen? Okay, so just a moment. Okay, fine. All right. So guys, some people already create all these graphs. So this M point is basically, yeah, this M is basically your mu value, which is the average value. Mu जो हमारा है, that is M, ठीक है? Which is basically this point. So we have a option to make this mu ऊपर नीचे, all of that. That is possible, ठीक है? तो हम लोग क्या कर सकते हैं, ये म्यू के साथ वी कैन प्ले अराउंड, एंड उसके अलावा हमारे पास जो अलग अलग वैल्यूज होंगी वो क्या क्या होंगी, व्हाट आर ऑल दीज डिफरेंट डिफरेंट वैल्यूज गोइंग टू बी, दैट इज व्हाट वी हैव टू फिगर आउट. e power minus x minus m divided by 2m, what is that going to be? Fine, so let's just reduce this value of m. Yeah. So m value, let's say, start from 5 till, let's say, 1000. Okay. And you have the option to move it around. You have the option to move it around. तो जब आपकी m वैल्यू जो है, मान लो 1 से स्टार्ट होती है, स्टार्टिंग फ्रॉम 1 से जब स्टार्ट होती है, तो क्या हो रहा है, 0 वैल्यू किस प्रोबेबिलिटी के साथ वो लेगी, दैट इज दिस. 1 वो किसके साथ लेगी, फिर 2 किसके साथ लेगी, फिर 3 किसके साथ लेगी, फिर 4, फिर 5, और इसके बाद वाली जो वैल्यूज हैं वो बहुत माइन्यूटली स्मॉल हो जाती हैं, दे बिकम वेरी 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 स्मॉल, राइट. एंड जैसे जैसे आपकी म्यू वैल्यू इज मूविंग ना, जैसे म्यू वैल्यू बिकम्स 4, so then this distribution starts looking like this, that value 0 with this probability, 1 with this, 2 with this, 3 with this, 4 with this, 5 with this. ये इस तरीके से ये अलग अलग नंबर्स आपके पास आते रहते हैं, राइट. तो जैसे जैसे ये म्यू वैल्यू चेंज हो रही है, स्टार्टिंग में ये बड़ा स्क्यूड था, स्टार्टिंग में ये डिस्ट्रीब्यूशन थोड़ा स्क्यूड था, राइट. फिर धीरे धीरे क्या हो रहा है, इट्स मूविंग लाइक दिस, राइट. यस और नो. तो इस तरीके से काफी सारे ग्राफ्स को आप यहाँ पे एनालाइज कर सकते हो. जस्ट अ मिनट, दे हैव गिवन अ होल लाइब्रेरी ऑफ दीज फंक्शंस. नॉर्मल डिस्ट्रीब्यूशन, बाइनोमियल डिस्ट्रीब्यूशन, बाइनोमियल dist. So let's say binomial dist. Okay, so there are different functions that are there. अब इसमें नंबर ऑफ ट्रायल्स आपको लिखने हैं. नंबर ऑफ ट्रायल्स, मान लो नंबर ऑफ ट्रायल्स मेरे पास 10 है, ठीक है, और मेरे नंबर ऑफ प्रोबेबिलिटी ऑफ सक्सेस मान लो 0.5 है, ठीक है. तो ये मेरे को क्या दे देगा, इट विल गिव मी दिस, it will give me what all possible probabilities I'm going to get for probability x0, and then 1, and then 2, and then 3, and then 4, and then 5, 6, 7, 8, 9, 10. ये सब देखने लग जाएंगे हम लोग. और फिर जैसे आप इसको और बड़ा कर देते हो, 100 कर दोगे, और इसको मान लो 0.1 कर दोगे, so these are different numbers that you're going to get. ये नंबर्स आ जाएंगे आपके पास. और मतलब ऑब्वियसली दीज नंबर्स आर बिकमिंग वेरी वेरी close to, ये सारे numbers हैं, ये अलग अलग आपकी probabilities हैं. Very close to zero it start becoming. जैसे जैसे आप इस तरफ जाओगे तो ये नंबर तो और जीरो के करीब आता जाएगा. जैसे 100 पे probability 0 0 0, it's so low that it's almost approximately close to zero. तो यहाँ पे क्या हो रहा है कि आप ये वाले जो नंबर्स हैं अलग अलग, ये 20 होगा और ये मान लो 0.4 होगा, then how does it look like? All these diagrams you can make and see how do they look. ठीक है, अब जैसे ही पॉइजन का भी डिस्ट्रीब्यूशन होना चाहिए, पॉइजन डिस्ट, एंटर द मीन.
Ma'am, here X is mu and Y is the probability, right?
This one, in this one.
Yes, ma'am.
So here, so they say the first thing is trial, what is value of n, and success probability 0.4.
Oh, okay.
So like you can make, you can keep changing your number of trials and your probability of success, and this graph will change. Okay. So like binomial dist, bracket open, trial, let's say 10, and then probability of success is 0.3. So then what are different points? These are the green ones. So all the green points are showing you that probability. Okay. So you can play around with it and kind of see what is the situation, right? Now let's try to see if binomial distribution is actually, how does a binomial distribution look like? So whenever I put binomial dist, it's already a function which is there in this platform. This website is desmos.com/calculator. तो इसमें इन्होंने देखो क्या लिखा हुआ है, एंटर द मीन, क्योंकि पॉइसन डिस्ट्रीब्यूशन में सिर्फ एक ही पैरामीटर होता है विच इज मीन, और ऊपर क्या क्या पैरामीटर्स होते हैं, ट्रायल और सक्सेस प्रोबेबिलिटी. तो दे आस्क्ड अस फॉर टू थिंग्स, हियर दे आस्क्ड अस फॉर ओनली वन थिंग. So let's say, मान लो, you remember that approximation which said that, whenever n value is greater than 50, so let's keep it 50 only. So let's keep it 60, and probability of success is close to 1. Let's say this is 1. Okay. So this is n value and this is p value. What is n times p in this case? 6. 60 times 0.1, it is 6. So let me just draw a Poisson with 6 value. And this is my distribution. And let me just change the color of this. Color. I want to change the color of this. Why do they have the same color here? So can you see that these numbers are very, very close? Like, this 0, these two numbers, they are very, very close, right? I should get a different, I should get a different color. Just a minute. Poisson dist 6. Okay, this is red. Great. Fine. All right. Can you see these two things? Are they very, very close? So you see, this red one is my Poisson distribution. This blue one is my binomial distribution. This number is 0.0018. This number is 0.00248. These two numbers are a little far apart. But obviously, when you try to see them like this, they are very, very close. Let's try to increase this number. That approximation was when n value is very large and p value is very small, such that n times p is my mu. So let me make it 100, okay? This is 100. And let's say this is 0.05, okay? And then what is 100 times 0.05? 5 only?
5.
Yeah, so let's do 5. So can you see that they are very, very close? तो इसका वो जो हम लोग अप्रोक्सीमेशन की बात कर रहे थे ना, उसका मतलब ये होता है कि अगर मैं बाइनोमियल डिस्ट्रीब्यूशन को देखूं, ठीक है, और अगर मैं पॉइजन डिस्ट्रीब्यूशन को देखूं, दे विल बिकम वेरी वेरी क्लोज टू ईच अदर व्हेन दिस n is very large and this n times p is equal to mu. But let's try to see if it is a small number. So if it's 20 and let's say this probability is 0.4, what is n times p here in this case? What is 20 times 0.4?
8.
8. So let's do 8. Here what is happening? This is 0.0037. This is 0.0. Yeah, 1 fraction. And then this is 1. And these two are very, very different. So this is what is the meaning, that whenever my number, and you see this number is such high value. This number is such low value. Whenever this is the value at 8, one value is this and one value is this. So they have a lot of difference. But this difference between Poisson and binomial will keep decreasing when this n value is becoming high, p value is going down, and such that this n times p is what my mu value is. This is the meaning of this approximation. If I start looking at it like this, here also I will feel like, okay, it's very, very close. But you try to see the pattern that, you know, this is what is happening. In this case, this red one is like this. It's going up till this point. It's like this. And, you know, this blue one is like this. Something like it's going up. And it's going down like this, right? So they are not quite converging. But whenever this n value becomes large and p value becomes small, such that this product is the mean value, these two curves starts to converge. So this is the meaning of that convergence. Okay, it's a very nice tool. You can definitely try to use this to do a lot of visualization. और ये जो tools हैं, इसको use करके आप सारे distributions बना सकते हो. You can make different kinds of distribution. In cake reference, let me know in case anybody is interested. I would love to share the resources to let you draw all of this. This is the main fun of statistics, I feel. Okay. All right. Are you guys able to understand what I wanted to tell you? Did you get a feel of how do they look like? Yeah.
Yes, ma'am.
Okay. Perfect. All right. Okay. Fine. Okay, guys, I think that's pretty much it that I planned for today's class. We can stop here for today and let's continue the new chapter from the next class. I don't want to start it like this. Let's start it in the Thursday's class. Okay. All right. Thank you so much.